Good day friends, welcome to my second video on half wave rectifiers. I am Dr. M. Santosh Rani. In the last lecture we have seen about rectifiers, uncontrolled rectifiers. Rectifiers convert AC to DC. They are classified as uncontrolled if diodes are used. They are classified as controlled if thyristors are used. In my last video I posted the explanation for uncontrolled rectifiers using diodes. And the applications of rectifiers are DC motor speed control, supply for inverters, electrochemical process, DC fraction, and HVDC transmission. Now, the half wave rectifier, uncontrolled half wave rectifier, as I already mentioned, here it is a diode usage and it is a uncontrolled rectifier. The explanation is there in the previous lecture. In this lecture, we will go in for a controlled rectifier wherein a thyristor is used or a SCR is used in the place of the diode. Before going into that, let me give an explanation on this sine wave. In India, we have the supply frequency as 50 Hertz, which means 50 cycles per second. So, in this waveform, you see one cycle. By 50 cycles per second, what we mean is in 1 second, there will be 50 such cycles. In just 1 second, if you see, there will be 50 such cycles. Now, when we have 50 cycles per second, let us just find out what is the time taken for one cycle. The time taken for one cycle will be 1 by 50, which will be equivalent to 0.02 seconds, or in simple terms we can say it is 20 milliseconds. And one cycle has got a positive half cycle as well as a negative half cycle. So the positive half cycle will last for 10 milliseconds and the negative half cycle will last for another 10 milliseconds. When we use an SCR, we will have to understand this and then only it will be easy for knowing the operation of the rectifier. And the markings here are, this is 0, the one cycle is represented by 360 degrees in terms of degrees. If in terms of radians, it is represented as 2 pi. 360 is equivalent to 2 pi. And it is 180 is pi. Then if it is 90 degrees, it is pi by 2. Like this it goes. The SCR is a device which has got three terminals. We will see why this finds a significance in understanding the operation. So we'll go into the half wave rectifier where SCRs are used. This is the symbol of a SCR. It looks similar to that of a diode, but there is one more terminal which is called the gate present. The diode, as we have already seen, will get forward biased if the anode is positive, cathode is negative. And here also the SCR is forward biased when anode is positive, cathode is negative. But there is a requirement for the gate current also. If the gate current is given and if the anode cathode is forward biased, then it will work as a closed switch. It will allow the current to flow through it. The time at which we give the gate current decides the time of start of operation of the SCR. So as I mentioned in the sine wave, in the sine wave, you can give the firing pulse for the gate at any point, like at 0 degrees or at 90 degrees or at 180 degrees or any degrees you want. So we will see the operation of a controlled rectifier. This circuit is similar to the uncontrolled rectifier, but the only difference is here we have the SCR. Now during the positive half cycle, as mentioned earlier, the primary will be having a positive and negative as shown. The secondary will also have positive, negative as shown. Now the SCR will be having positive at the anode, negative at the cathode, And the gate current, if it is given at the start of the sine wave itself, the output will look similar to that of a diode, like this, the very first one, where you have the current flow starting at 0 itself. So when the gate current is given at the start of the sine wave, the output will be looking similar to that of the diode. During positive half cycle there is going to be current in the load, during negative half cycle there is no current, because it is going to get reverse biased. If the gate pulse is given not at 0 degrees but at a later stage, say at some point away from 0, and if the SCR is forward biased during positive half cycle, we will see that the current conduction starts from the point where the gate current is given. So we do not get the full positive half cycle as the output, a part of the positive half cycle only as the output. In the negative half cycle it is reverse bias, so it does not conduct. So in the next positive half cycle also it will start conducting from the point where the gate signal is given. So this second one also is similar. Here the gate pulse is given at a much later stage than the previous one. So here we get output voltage which is different from the that we get from a diode. So in the case of a controlled rectifier, you can get any value of DC output based on the point at which the firing pulse is given. So the firing pulse is represented by alpha. It is represented by alpha, and that is called as a firing angle. If I say alpha is equal to 0, the output available is similar to that of a diode. Firing angle, yes. And if alpha is lesser, you get a voltage which is lesser than the previous case. If alpha is more, again you get output which is much lesser than the previous case. So you can have the understanding of the firing angle, definition of the firing angle as the angle between the zero crossing of the input voltage and the instant the thyristor is fired. So using a SCR, we will be able to get variable values of DC voltage from a fixed AC voltage. But in the case of a diode, we can get only a fixed DC voltage. That's why this type of controlled rectifiers find application in DC motor speed control. Thank you.